Hey, how's it going? I'm Nick Bergeron, and this is my Physics 2 Lab 1 report. So, why is it not going? Okay, so the lab objectives was to charge tape to showcase the effects of attraction and repulsion, as well as to showcase the interaction between two different forces, such as gravity and electricity. So here is the video of me with a charged piece of tape, and shows the attraction to my hand. So there you go. As you can see, it is very clearly attracted to my hand due to the tape being charged. And I believe that two pieces of charged tape would repel because since they are going through the same process of being charged, they would therefore have the same charge. And as we all know, two objects of the same charge repel. And then furthermore, a positively charged U-tape would attract a negatively charged pen because they are opposite signs and they attract, but it would repel but a negative piece of U-tape would repel a negatively charged pen because they are similar, but they would well, since they are the same charge and since they would repel. Now, if it would be brought near a book, there would be little movement, but there would be an induced dipole on the book since there is an induced dipole on everything that is a neutral object. But it wouldn't be enough to actually move the tape in any meaningful or recordable distance. So then, when you took a pen and when you charged a pen negatively by running it through your hair, the U-tape would then attract it. So therefore, the U-tape is positively charged. And now we showed the balancing forces. So if we can assume that when the tape is stationary at the top of at its utmost height, there's zero net Y force since it is not going in either direction because the gravity or the gravitational force and the electric force are canceling out, and the only two forces acting on it are the other piece of tape, the one right there, and then the gravitational force of the Earth. So the force diagram would look like you would have your tape right here, and then pushing up would be the repulsion from the tape, and pulling down would be the gravitational pull of the Earth, and the two arrows would have the same magnitude, so they would be the same length. And then you also must record the mass of the tape and distance between the two pieces to find or to calculate all the charges. So as we can see here, the tape moves up as I bring it closer, and then it stops right about there, maybe about 2 centimeters up, due to the forces being canceled out. Let me next slide. All right, so here are my calculations. So I calculated that the mass is equal to 0.0025 kilograms, which I found that by the length is 24 centimeters, and which is 0.24 meters, and the density is 1 gram per meter, so it's 0.24 grams, which is 0.0024 kilograms, which you need to calculate the force from the Earth, which is times 9.81, which is the gravitational constant. You get 0.0225 newtons. The distance between the tape between the two things of tape is about 2 centimeters. So as you can see there, I was able to calculate it to calculate the charge of each to find the charge of the tape, which is 1.1 times 10 to the negative 8 coulombs, and then electrons. I used this formula to find 6.8 times 10 to the negative 10, and total atoms. I divided the I divided the area of the tape by the amount of atoms per each square meter to get 1.8 times 10 to the negative 17. And the ratio, I divided the number of electrons by the total atoms, and I get 3.8 times 10 to the negative 7 for is that 10 to the yeah. So per each atom. So it is a deficient ratio. And then finally, I made a GlowScript code, a Python GlowScript to showcase this. As you can see, both forces are equal and opposite, so there is zero net Y motion, and here are further more calculations done by the code as well. And that is all. Thanks for watching, and I will drop the link to the code in the YouTube video description. Thanks for watching.